Hewlett-Packard Enterprise has supported the high-performance computing market for many, many years, and in fact, we are the leader in delivering systems and number of customers in that market. One thing that our research has led us to is the real need for a new type of processor to meet the demanding needs for future HPC systems. We found that the ARM processor and the ThunderX2 processor specifically as meeting some of these requirements very well.
So the collaboration started about a couple of years ago, and it started even before we had the silicon ready. HPE developed the Apollo 70 platform in parallel, and they also brought a number of ecosystem partners, people like Red Hat and SUSE, who delivered the operating system, Mellanox, who provides IB connectivity solutions, and AMD, which delivers GPU solutions.
So for the Apollo 70 development project, we had about a dozen strategic customers that we were collaborating with throughout the process, Lawrence Livermore being a very important contributor.
The overall mission of Lawrence Livermore National Laboratory is science in the national interest. The collaboration between HPE, Cavium, and those of us at Lawrence Livermore National Laboratory, as well as other customers, other sites deploying Apollo 70 systems, is a critical aspect of our interest in these systems. And that collaboration has been reflected throughout both companies.
And one specific requirement that Livermore brought to the table was their requirement for GPUs integrated into the Apollo 70, which of course we did and are working with them even today on demonstrating that technology.
Our workloads involve multi-physics simulation. Running our workloads on Apollo 70 really works well for these types of workloads because of the advanced capabilities that were built into the chip for compute capabilities, and also the large number of memory channels which then support high memory bandwidth onto the chip.
ThunderX2 processor is differentiated by having more cores, which actually benefits compute-intensive loads such as the ones which Lawrence Livermore runs, and more memory bandwidth. It's 33% more memory bandwidth.
So one thing that we've heard from our customers loud and clear in the high-performance computing space is more memory. And in the case of Apollo 70, that's precisely what we're delivering. We've packaged ThunderX2 processors very densely into an Apollo 70 chassis. In such a way, in a very dense package, we're providing extreme performance and phenomenal memory performance. And this is precisely what our customers are demanding.
Having a company like HPE with its reputation for innovation and quality, and having a platform from them and their support model, service model, and their sales force behind this product is a great endorsement of the readiness of the ARM architecture and ThunderX2 for mainstream high-performance computing applications.
With the HPE Apollo 70 and the ThunderX processors, we found that we were offered a nice combination of both being able to innovate in terms of the hardware that we were deploying while providing a software ecosystem that was comfortable for our users.
At Hewlett-Packard Enterprise, we value not only our customers and partners, but the community as a whole as we continue to develop technologies that will lead us to exascale computing in the not-so-distant future. And that's clearly the path that we're on with the Apollo 70 today.